There you go. Okay, ladies and gentlemen, let's get started. I hope you had a refreshing long weekend. Back to it. So a few housekeeping notes before we get back to lecture. Just having a look at the schedule for a moment. Last Thursday, forgot to turn on the microphone when I recorded the lecture, so not very good for you without the sound. So I plugged in 2 lectures from 2 years ago that covered the same material we covered last Thursday. So from time to time, if something happens with the recording, I'll just put up videos from 2 years ago. Okay, let's talk about Deliverable 1. According to the yes-no platform spreadsheet, at least 44 of you managed to get everything installed and completed. I think the number is much higher than that. However, there is a significant fraction of you that are still having installation issues. As I mentioned last week, we will waive the late penalty for Deliverable 1, given the extra headaches that sometimes crop up with installations. Despite that, you still have to finish Deliverable 1 because, as I mentioned, all of the deliverables are cumulative. So if you still have not completed Deliverable 1, make sure you get on that as soon as possible this week. Come and see the TA. Sorry, I forgot to mention the TA is a Windows person. Clearly, I am a Mac person. If you have Windows issues, email the TA, go see the TA during his office hours. Make sure you get all your installation headaches out of the way. If you're a Mac person, come and see me during my office hours. If you can't make my office hours, email me and I'll schedule some time to meet with you, hopefully earlier in the week rather than later. So if you are still struggling with Deliverable 1, you still have to finish it, and we are not going to extend a deadline for Deliverable 2. We don't want you getting too far behind, so there is going to be no extension on Deliverable 2. We need to make sure we stay on top of things. So for those who are still working on Deliverable 1, please try and get that finished as soon as you can this week. You'll notice that at the end of last week and into the weekend, I was updating the instructions given what I learned from all of you with your different platforms. So step 16 has become a little bit complicated now. For those of you that are having issues on a Mac, you might have error messages as printed in step 16C. I apologize, it's so small. I wanted to make sure to get it all on the same line. You might see that error message, or you might see the error message in step 16D. Everyone I saw who had problems with 16D, once you fixed it, you saw the error message in 16C. You then worked your way through 16C and it worked. So if you're getting a little bit confused, most people hit 16D, have to go back to 16C and then can move on, thankfully, to step 17. Okay, if you're a Windows person, thank you to some of you who figured out about moving the library files up into your del1.py directory. That seemed to work for most of you. If that isn't working, again, make sure to see the TA. Okay, aside from specific installation questions, any other questions about Deliverable 1? No? Okay, so we're now moving on to Deliverable 2. As I mentioned, you're going to be submitting your deliverables at 11:59 p.m. on Monday, and then the following morning, like today, I'll talk briefly about your next deliverable, which is now available, Deliverable 2. And in Deliverable 2, The main work here is you're going to be expanding your work from drawing in 2 dimensions to 3 dimensions. So when you finish deliverable 1, you have a dot that is in the XY plane, and the position of that dot is being dictated by the X and Y coordinate of the distal part of your distal phalange, which is the tip of your index finger. So it seems like a relatively small step to go from 2 dimensions to 3 dimensions. However, it's a little bit more involved than that. In order to draw in 3 dimensions, we're going to continue working with matplotlib, but you're going to be importing on step 8b here Axes 3D, which allows you to draw in 3D, and Axes 3D is a part of the matplotlib toolkits. For most of you, that's already installed if you have matplotlib. For others, you might have to install MPL toolkits independently. So again, for deliverable 2, for a small fraction of you, there might be some installation headaches. So again, get started on deliverable 2 as soon as possible. If you get stuck, if you have a hard time installing MPL toolkits, come and see myself or the TA. Okay. So at the end of deliverable 2, what you should see is something like this, where now you're using the data coming off the leap motion to, instead of drawing a dot, you're going to be drawing a total of 20 lines. You're going to be drawing a total of 20 lines, 4 lines for each of the 5 fingers, and you're going to be referring back to that Wikipedia page that I linked to, which shows all the bones in the hand. Each finger in your hand is made up of a total of 4 bones. We're going to be drawing all of those. Your thumb only has 3, so leap motion cheats a little bit by drawing the base part of the thumb as just a 0 length line. Keeps things simple for you. So every time through that main loop that you've created in deliverable 1, every time through you're going to be drawing 20 lines in 3 dimensions. You then erase all the 20 lines, go back to the top of the loop, go back through, draw 20 lines again, and around and around and around, and you get a 3D animation of the hand. And that's the basic animation we're going to be using for the rest of the deliverables. Pretty straightforward, I think. Any questions about that? Same thing as last time, you're going to be capturing a few videos as you go through the deliverable, stitching those together into a YouTube playlist. Make sure that the playlist and all the videos are set to public so the TA can grade them for you. Okay, that's all I've got to say about deliverable 1 and deliverable 2. You may have noticed that there's a few more empty chairs today than there were last week. Some students have decided that this is not the right course for them. If you are still deciding and you decide not to continue on with the course, please do remember to return the leap motion device to myself or the TA. You can also drop the leap in my mailbox in Voti 332, which is the CS office. If you know somebody in this class who has dropped it, please ask them to return the leap device to us. That would be much appreciated. Thank you. Okay, so let's get back to the lecture material now. We're working our way through this sort of introductory theme on HCI, and the basic message here is how HCI differs from sort of traditional computer science. We can't just focus on the code. We need to think about the interaction between the code and whoever is using it or being affected by that system. So it requires us to think a little bit differently. We're going to finish up lecture 2 in a moment and then move on to lecture 3, where we're going to look at something called PACT analysis. This is a good acronym to keep in mind everything we need to think about when we're dealing with HCI, which is we're trying to develop technology, which is the T in PACT. We're trying to develop technology for people performing an activity in a context. So who, what are they doing, and where and when are they doing it? PACT analysis. We'll talk about that. It's the beginning of our attempt to try and formalize what we mean about thinking about people when doing HCI design. And then speaking of design, on Thursday we'll start to move on to how do we actually take this analysis and then gradually start to render it into software and or hardware. Okay, so back to lecture 2. Just a very brief refresher here. We started by looking at humans and computers as input cogitation or computation and then output. And we very quickly saw how that doesn't really make a lot of sense. And we switched, or we're going to try and switch our way of thinking to John Dewey's way of thinking, is that people tend to reach out into the world and push against the world literally or metaphorically and observe how the world pushes back. So humans enter into all the time these continuous feedback loops with inanimate objects out there in the environment or other people in their social environment, and in just the last few decades now, machines. And we bring a lot of our intuitions about how the world works and how people works, and we unconsciously apply that to our interactions with technology. So when we're designing technology, we want to make sure to support those intuitions rather than break them. If we support those intuitions, we can get away with a lot less documentation and explanation. A user will walk away from your system saying, yeah, that was intuitive, it made sense, it was really easy, I remember how to use it, because they're relying on their intuitions that they built up from other systems. Okay, we saw sort of a traditional form of this interaction where you're surfing the web, and then looked at a very different interaction which is much more modern and much more difficult to pin down, right? It's not occurring just between a person and their laptop sitting at a desk. It's sort of suffused into the world. We have someone moving through the environment. They're carrying one of these things with them. That environment is wired up in a certain way as well. So there's still this interaction going on all the time, but it is very different. It's real time. It's involving a lot more input-output devices than in a more traditional session with a traditional machine. So designing for this kind of scenario is really what we're focusing on in this course. Okay, we looked at pros and cons of people and machines, trying to bring together the best of both worlds. We're going to talk about interactive systems. These are things that have some electronics in them. And then we talked last time, where we touched on this fact that this course is going to be very broad rather than deep. We're going to draw on a lot of different disciplines to inform how we go about designing for HCI. And we ended last time with interaction. What do we mean by the I in HCI? Well, when someone is interacting with a technology or people or objects in their environment, there are a lot of different forms of interaction that are going on, some which are more obvious than others. And the key is to, as we design, clarify and understand these subtle, perhaps unspoken forms of interaction that are going on. If you watch somebody using their cell phone or a laptop or the leap motion device, you can see all the physical interactions that are going on. They're pressing a button, they're waving their hand over the device, they're looking at the monitor, which is sending information back to them. The physical interaction part is pretty obvious. The perceptual interaction is, again, maybe you can see and hear what's going on, but some of those things are a little bit more subtle, and we'll see why in a second. Most importantly are the conceptual interactions. So humans, whenever they're interacting with things or people or machines, are predicting what is about to happen in the interaction. Recent findings in neuroscience are proving basically that the brain is a prediction machine. You're making predictions all the time. And whether those predictions end up being correct or not dictates what you're going to do next. So when someone is interacting with the technology, waving their hand over the leap motion device, they're expecting the leap motion device to talk back in some way, right? That might be flashing a light on the device itself, or something moves on the screen. If it doesn't, then they're pretty sure the machine either isn't working, or it's off, or it's broken, or they're not doing the right thing, right? So we need to keep this in the back of our mind, that people are always forming these predictions about what's going to happen next. And where do these predictions come from? These predictions, again, come from their experiences in the physical world, but also from other forms of technology, right? A green light, if you wave your hand and a green light comes on, that probably means the leap motion says, I'm on and I'm listening to you, right? So we want to try and think about, for example, examples where there's feedback or something that's helping to support the user's prediction and understanding about what's going on. What are some obvious other forms of prediction that machines give back to you to help support your understanding of what's going on, aside from green lights?
If your computer's being slow and you put bunch will often go into your mouse will move to an icon that doesn't have a pointer.
Okay.
To indicate that it's still working.
Absolutely. So it might take away control for a moment and say, just hold on a second, I'm thinking. That's a good example. What else?
More simple machines can sometimes make a sound like a card reader, like a credit card will make a little beep when it goes through.
Absolutely. Just, I got it. I heard you. I have it. Let me do my thing. Simple things like that. What about progress? Sometimes when you're interacting with the machine, you're trying to do something. How do you know how far along you are in the process?
Progress bar.
The progress bar, right? Or the spinning wheel of death, which is supposed to tell you that progress is being made, sometimes not. How far along are we in lecture 2 here? Is there anything on the screen that's telling you how far along we are? We're at 15 slides of how many?
Well, there's a scroll bar.
There's a scroll bar, right? So you can actually estimate it, for those of you that are paying attention, from the scroll bar. There's not much left in Deliverable 2. There's nothing explicit telling you how much further we are to go, but most computer technology these days has either an explicit signal like 15 of 17 or whatever it is on the slide itself, or some indirect measure showing you how far along you are, right? That's an important part of a prediction. How much further is there in this particular lecture? How far along am I? How close am I to completing whatever task I'm trying to complete with the technology? These are all sort of signifiers that help you understand and support your prediction about what's actually going on. Okay, let's have a look at an example. This is now a little bit of a dated example. Anybody remember the Nintendo Wii Remote? It's not too ancient yet. Okay. All right, so I didn't have one of these myself, but apparently you take the sensor bar, which has these 5 LEDs, 5 at either end, you put it above or below your television, and then you hold on to the Wii Remote and point it at the TV, and this remote can then give you back 6 numbers, 3 axes of orientation, so this is yaw, pitch, and roll. You should be able to see it visualized here. So if you have an object floating in 3-dimensional space, we want to ask how it's oriented in space. We need to give 3 numbers, how much it's pitched forward and back, how much it's rolled about its long axis, and how much it's yawed around the vertical axis. If you give those 3 numbers, you can exactly specify how something is oriented in 3D space. How do you think the Wii Remote knows those 3 numbers?
By viewing the LEDs and then doing calculations to decide where it's going to go.
Okay, possibly.
Accelerometer.
There's also an accelerometer inside. So there are 2 sensor systems in the Wii Remote. An accelerometer, which actually gives you information about how much you're accelerating about yaw, pitch, and roll, right? How fast you're rolling or yawing or pitching, which is given by one sensor system and corroborated by the LED lights. So there's also an optical sensor inside the front of the Wii Remote that can see where those lights are and say something about the orientation of the Wii Remote.
It gets triangulated by 2 different sensors in the sensor bar.
Exactly. So it also gets some triangulation, and this is something we're going to see when we talk about embedded devices, devices that are directly sensing the environment. They often use multiple sensory systems to corroborate or make sure they have the right information. Humans also do this quite a bit. Okay, so that's rotational acceleration. What about position? How does the Wii Remote know where it is in space? So again, that's 3 numbers, right? The X position, Y position, and Z position of the remote.
You could get 2 of those by looking at the sensor bar.
Absolutely. Which 2?
You could definitely get left, right, and.
Absolutely. Yeah. So the relative positions of the light, the 2 sources of light relative to the Wii Remote will give you X and Y. What about Z, forward and back? How bright and how far apart the 2 sources are, right? Obviously, the closer the Wii Remote is to the television, the further apart those 2 groupings seem. That's why there's 2 groupings rather than than 1. So given those two sensory systems, it can give you back these 6 pieces of information, and then once you have them, what can you do with them? Well, you can create video games. There's one game which is a bow and arrow game. So the idea is you shoot the arrow from the Wii Remote at the television. So let's think about the physical interaction. That's pretty straightforward. If you're the programmer of this game, you know where the Wii Remote is relative to the TV, and you know the direction of the Wii Remote, which is going to matter if the person is trying to hit a target. There's some interesting perceptual interactions in it, and these are based on sound. So if you press the button on the Wii Remote, you hear the sound of letting go of the arrow. And then a short time later, and that comes from a microphone or speakers on the Wii Remote. So you hear it coming from the actual Wii Remote, which makes sense because if you were actually shooting a bow and arrow, you would hear the release of the arrow near to your hand. So it's supporting that intuition of what it's like to actually shoot a bow and arrow, even if you've never really done it in real life. You would expect to hear the sound of release here rather than where the arrow is going. And then a short time later, you hear the thud of the arrow hit the target, and the sound is sent out by the TV speakers, which again supports your physical intuition about bow and arrow, right? If your arrow actually hits something, if it's not too far away, you'll hear the sound of it hitting the target distantly. Okay, that's part of the perceptual interaction. If I play that a couple times, if I play this game a couple times and then take a few steps away and press the button again, let's think about the conceptual interaction. What are the kinds of predictions that I'm making about what's going to happen if I take a few steps away and release the arrow again?
And more time will pass for where you hear the thud.
Absolutely. So there's a short time delay between the sound at the remote and the TV, and you're probably not aware of it if you've ever played this game, but your brain is expecting to actually hear that time differential. And if you've actually shot a bow and arrow enough, your brain will have a prediction about exactly how long that delay should be. And experienced archers who play this game, they'll tell you it's off by 1/10 of a second, right? So again, kind of a dated example, but a great example of putting together these 3 forms of interaction. If you're developing this as a training regime for actual archers, you better be very, very careful about these timing issues and the sounds. Maybe for the casual player, it doesn't matter, but you want to make sure that you get that right, and it is a sort of a subtle thing. If you're the designer of this game and you don't really know much about archery, you might miss these little subtle aspects, right? The sound of an arrow hitting a target obliquely is also different from the sound of an arrow hitting a target dead on, right? That matters, and maybe in retrospect it's obvious, but these are the kinds of things as HCI designers we want to practice and be able to think of before we start to get complaints back from professional archers. Okay, so let's start to move now from the interaction into what do we really mean by putting people first, right? Again, that's very hand-wavy, very vague. What does this actually mean? Well, in the remaining part of this lecture, in the next one, we're going to start to unpack what it means to put people first, right? We want to, first of all, pay attention to their expectations and predictions when they interact with the technology. There's a lot of other things we need to keep in mind, right? People are pretty complicated machines themselves. What are the things we need to think about? The first thing, which most computational people or technically minded people miss altogether, is focusing on what people want to do rather than what the technology can do, right? Probably none of you have used a leap motion device before. It's pretty cool. You can do quite a few things. Do things in real time, 2D, 3D. You can put in audio if you want. There's a lot of stuff you could build on top of the leap motion device. If someone's trying to get the leap motion to recognize their hand and particular gestures, that's what they want to do, is all the bells and whistles you're adding in actually necessary? In Deliverable 2, you're going to go from 2D to 3D. I haven't really told you what we're going to be doing with the deliverables, but you could ask already, is that even necessary? For a lot of tasks, it might be useful for the user just to move around a dot in XY rather than in XY, YZ. So we want to try and focus on that before we get caught up on what can we do with the technology. If you look at a lot of the killer apps in HCI in particular, and computers in general, most of those killer apps are designing new ways for people to socialize, right? Going back to social interaction. For a lot of people, technology is only as good as it allows them to connect with other people more often, in richer ways, across greater distances, and so on. Okay. Related to that, but not exactly the same, a lot of killer apps have to do with maximizing the synergies in collaborative work. We're going to look at a subfield inside of HCI called CSCW, which is computer-supported cooperative work. So a big hallmark of modern society is getting lots of different people with lots of different skills to work together on a common task or project. And a lot of HCI technology is about allowing them to do so faster, with more people, less error-prone, and continuously, all the time. Sometimes HCI technologies involve people in the design process themselves. So instead of using a static piece of technology that never changes, it becomes more and more easy for people to modify the technology itself, to add content, modify the content, or even get down into the plumbing itself and modify the system itself. Okay, and then finally, this one, which is becoming very important in just the last few years, is designing for diversity. People differ along lots of different axes, and if we're going to design HCI technology and deploy it out in the world, is everyone going to be able to use it? Are we aware of the differences in people that are going to be relevant when they start to use your technology, right? Does it matter that people have rings on their hands or not when using the Leap Motion device? Okay, what are some examples of technologies that illustrate these 5 aspects of HCI technologies? Let's go with the first one. What are some examples of technologies that clearly focus? The hallmark of that technology is clearly it focused on what people wanted to do, and it's sort of less important on all the things that technology actually could do. Any ideas? What is one of the main things you want to do if you're trying to develop some technology to help someone, rather than focusing on making the technology do everything it could possibly do?
Like voice commands, like Alexa and Siri.
Okay, how so?
Even though voice technology can probably do a lot more things, and it can be integrated in like every part of life. Generally, it's just used to like make reminders or to get the weather, stuff like that.
Okay, yeah, it's a great example. So all the voice recognition technology that's coming out now, voice recognition and natural language processing is notoriously difficult. But some things are easier to understand than others, right? Alexa, play, ... the name of my favorite song, right? So a lot of effort, especially now, is going on to making sure that those voice recognition technologies can recognize simple, common things you want it to do, which seems to be for most people to play music playlists, but that's fine, right? Rather than designing the technology to enter into an interesting philosophical discussion with the user, right? Let's leave that till later. Let's focus on what most people want to do with Alexa, which is not to have an interesting conversation about the meaning of life, but to get Alexa to remind me of class on Thursday and play music and so on. Right? Other examples?
Like autofill when you're texting.
Autofill, that's a great one, right? So just fill in the remainder of the word and focus on the most common usage of the word, or maybe the most common usage of that word by the user. You could also start to ask, we could look at what everyone else is doing and how often they autofill that particular word. Is this their native tongue? Maybe we want to make sure there's common spelling mistakes to people coming from other languages for which English is not their second language. Yeah, we could do that too. You could very easily start to go down a slippery slope of making autofill very complicated. And it might help some group, some demographic, like non-native English speakers, but let's focus on the simplest explanation of TH, what comes after TH for most people. Focus on that. So one good thing to keep in mind here is the KISS principle, right? Keep it simple, stupid. There, you could very easily start to make the code that you're wrapping around Leap Motion extremely complicated. Keep it simple and allow it to just do, or allow it to support just what people want to do. I think most people today use Google, right? I don't know if you remember what came before Google, but there used to be these fantastically complex pages with hundreds of links and images and moving GIFs, and somewhere in there was a search bar where you could click on and type in what you wanted to look for. There were a lot of innovations behind the Google PageRank algorithm, but the HCI innovation was a white blank page with a bar in the middle, right? Most people that are using a search engine, what do they want to do? They want to type in something and search for that keyword. That was one of the innovations that Google got right and allowed them at the beginning, when there was a lot of competition among the search engines, to beat out the other competition. Okay. Designing new ways to connect people to people. There's so many of these out there now. What are some obvious examples? Snapchat. It's going to ask, do people still use Facebook? Is that, I don't know if that's still a thing. Okay. What are the aspects of social interaction that the different social media platforms out there are tapping into? Right? Again, there's lots of technologies you could create that would try and help people connect in different ways. What are the specific aspects of social interaction that some of those are targeted at?
Right now, most social networking technologies focus on letting you share what you're doing in a single moment with your friends instantaneously.
Absolutely, which seems to be, in retrospect, that's what a lot of people seem to want to do. This was clearly not obvious at the beginning of the social media, the beginning of development of social media, right? There's been a lot of social media platforms that have come and gone, and along the way, Silicon Valley and the other people making these social media platforms have started to realize, what do people actually want to do, right? What is it that they want to do? And one of them is share what they're doing at the moment with their friends, and that's about it. At least that's most of what they want to do. Okay. What about this one? What are some technologies that help larger and larger numbers of people work together better?
We say GitHub, or is that too?
GitHub would be my example, right? So again, there have been a lot of version control and software development support platforms over the years. They have also come and gone. Why is GitHub seem to be the obvious answer for now? When I teach this class next year, maybe it'll be something else, but at least for now, GitHub is dominating the field. Why?
One big thing that's free.
It's free, that helps. Yeah, absolutely. Makes it accessible to a lot of people.
It's relatively simple to use.
It's simple to use. Why? What intuitions about code development in a social setting where you got a lot of people working on a code base, what is it about GitHub? What intuition is it drawing on that makes you say it's simple? There's actually a lot of moving pieces to GitHub if you play around with it, but it feels simple because...
Syntax architecture?
Sorry?
The syntax architecture?
Okay, what about the syntax architecture?
So like the words that they use to do commands and flags are like relatively intuitive.
Absolutely. So whether you're familiar with GitHub or not, you've probably heard about pushing and pulling from a repo, right? Remember what we were saying before about people drawing on physical intuitions, right? Push and pull, right? That sort of makes sense. If I'm pulling something, I'm drawing something from out in the world closer to me. And if I'm pushing something away from me towards something else, right? It seems so obvious in retrospect, but that aspect, the verbs that are used in GitHub appeal to our intuition about how the physical world works, right? I push this thing and now it's away from me. What else about GitHub makes it so simple? There's a lot of other metaphors and things built into GitHub that seem to help.
Well, even if it is really complicated, there's a lot of information about it. So like a lot of people use it. So if you ever do run into a problem, you just Google it and find
Absolutely, right? So it's been accepted by a large number of people, and we see this with a lot of social platform technologies. You get this virtuous cycle where if enough people use it, they put up enough documentation, which makes it easier for the next person to use it, and once the ball gets rolling, it becomes very difficult for other platforms to compete, right? Why was it able to get the ball rolling in the first place? Because it seemed simple to people compared to with what else was out there. What other metaphor is at the heart of GitHub aside from push and pull?
Trees and branches.
Absolutely, right? So the whole metaphor, not just the visual metaphor, but the conceptual metaphor for GitHub is the tree, right? So if I see some code and I start to work on it, and Jack also starts to work on it, and we start to work on it and add different things, then the code base on Jack's machine and on my machine are moving away from one another. They're branching away from one another. If Jack and I want to combine our contributions, what do we do with those two branches? Even if you've never used GitHub, you kind of know what the word would have to be, right? Compress or merge or push together, it's merge, right? So they thought very carefully about this conceptual metaphor, which makes it such an engaging piece of software to work with. Okay. What about some technologies where people can easily get in and modify the technology itself? It's become easier and easier over time. Yep.
Video game modding.
Video game modding, yeah, that's a good example.
Squarespace.
Squarespace. Okay, you stumped me. I don't know what Squarespace is.
It's like if you want to make your own website.
Right.
It gives you the tools and stuff like that. So like WordPress.
Absolutely, WordPress, right? All the website development tools, right? In the old days, you wrote HTML by hand. Now anyone can sort of make a web page. And again, a lot of these website development platforms have come and gone over the years, and the ones that tend to survive are intuitive in some way, right? A lot of them rely on dragging and dropping content onto a page, right? Drag and drop. Those verbs should be a reminder to you again that people are trying to appeal on our physical intuitions. Wikipedia is a great example, right? It seems like magic at the beginning. Nobody thought this would work. Why would people ever want to become encyclopedists as a hobby? It seems crazy, but clearly it wasn't, right? If you lower the barrier to entry, you make it easier and easier for a greater number of people to create the technology itself, then you often have a powerful technology on your hands. So think about all the technologies that are out there where you don't necessarily need to know how to code to actually get in and make fundamental changes to the technology itself. There's a fair number of them out there. What are some aspects of software or hardware where the designers clearly took time to think about all the ways in which people differ and to make sure that that software is going to support those differences?
Color blindness filters.
Sorry?
Color blindness filter.
What is a color blindness filter?
Like they'll change like if there's like red and green or like the important distinctions on the screen, they'll change it to like blue and orange so that people with or whatever settings they might have for different types of color blindness so that people can actually distinguish between colors.
Yep, that's a great example, right? We were just talking about red, green tends to mean go, red tends to mean stop. Unfortunately, a common form of color blindness in a significant fraction of the population is red-green color blindness. So we need to deal with that somehow. Color blindness filter is a great example.
Like accessibility in the control panel.
Accessibility, right? So they're right up at the top level of most control panels is something that says accessibility. If you can't see or you can't hear what's going on the machine, it's relatively few steps to get in there and fix it.
I was gonna say that Chrome has like a lot of extensions that it supports that will help you like either change the size of the font or the text of the font or read it out loud to you or whatever you need.
Absolutely. So if you're designing technology and you're hiding the ability to change font or visual audio aspects, you're gonna marginalize a good fraction of the population. Okay, so again, I think we mentioned some of these. You don't have to write all these down. I think given our discussion, you can sort of figure these out now for yourself. There's some examples here of where this was done particularly well, but it's also interesting to think about technologies and where this was done particularly poorly. It's also very, very instructive. right back at the beginning, for mice that had a wheel in the middle, usually rolling the wheel increased or decreased the size of the font, right? So make it really, really top level, very, very easy to change the settings for people that had more or less visual acuity. Okay. All right, that's it for lecture 2. So let's move on now to lecture 3. We're going to talk about this idea of PACT analysis, which will take us deeper into our discussion of what does it actually mean to sort of think about people when we're designing technology. Well, in PACT analysis, we're going to not just think about people, we're going to think about what they're doing or what they want to do. And most challenging is to think about the context. And we'll see what we mean by that in a moment. But for now, you can just sort of think of context as when. Where and when are they performing the activity? So the activity is the what, people is the who, and then once we've thought carefully about P and A and C, only then should we start to think about T. Often if you start to think about T before thinking about the other 3, you end up in trouble. And there's a lot of great examples of gaffes out there on the internet of developers or coders that didn't think about that carefully and regretted it after the fact. Okay, so people, who's going to be using it and who's going to be affected by it, right? Remember our example about Google Glass? The people that had the biggest problem with Google Glass were not the people that were wearing them. So when we want to think about a particular technology or start to think about an activity, who's going to use it and who might be affected by it, even if they didn't buy the technology, even if they don't know the technology exists. This is often the one that trips up, again, new technologies. Okay, what are people doing and in what context are they doing it? And then finally, we can start to think about the technology for that. Okay. So let's look at a couple of examples. Some of these are a little bit tongue-in-cheek. Let's take 3 examples, and in each one I've sketched out the P and the A and the C. So teenagers is the P here. The activity is texting, and the context is they want to do it sort of with their friends. Okay. Here's another one. People fly drones. There's the activity, and they're going to do it together. So a bunch of people flying a bunch of drones together. Finally, we might have a person working alongside what's known today as a cobot. So a cobot is any robot that is going to be working in close physical proximity to a human. This is one of the most famous cobots out there at the moment, the Baxter robot made by Rethink Robotics. Okay, so again, we're just sort of doing this at a very high level, and you should already start to think about aspects of the technology that matters. What are some of the aspects of the T that are going to matter here?
If they're in the same physical space, you want to be able to predict where the robot's going to move so you don't get hurt. The person is going to have to be able to predict.
Absolutely, right? So that specific consideration is a part of safety, right? So the first thing we're going to think about when starting to design cobots, either the hardware and the software, is safety. And one aspect of Baxter is being able to make sure that the person working with Baxter can tell what Baxter is going to do next. If you're designing a robot probe for NASA and it's going to go out and explore the surface of Mars, safety doesn't matter. As far as we know, there's no one out there for the robot to bump into and harm, right? So kind of similar technologies, a robot, but depending on who's going to use it and where and in what context, that greatly influences how you start to think about the technology. Okay. What about people flying drones together? What might matter there?
Not like getting the signals mixed so that everyone's able to talk to their drone exclusively.
Absolutely, right? So who is talking to which drone? That matters, and that can become pretty complicated. When I said they're going to be flying drones together in what way? How close are those drones going to be? How close are those people going to be? So we might spend some time here trying to sharpen our definition of P and A and C before moving on to T. Okay, so what I'm going to do now is take these 3 examples and I'm going to change the context. And I want you to pay attention to how you're thinking about the technology changes. Teenagers are going to be texting messages to friends while they're driving. People fly drones together during a large-scale protest march. And a deaf person is working in close physical proximity to a co-robot. So take any of those three you want. How did the change in context change your thinking about the technology?
If a deaf person is working with a robot in an assembly plant, obviously they won't be able to respond to like sound cues and stuff like that.
Absolutely. So if Baxter says, I'm about to reach out my left arm for that widget, it's not going to help a deaf person. So it turns out that Baxter does not use audio cues for that. How does Baxter signal to the human about what it's going to do next? The hint is in the picture itself.
Is it the screen, like it looks at something and then it reaches for it?
Absolutely. So if you look carefully, you'll notice that the only thing on the screen are eyes, right? As I'm lecturing here, from time to time I'm saying something and I'll look to my left, and instead of you all looking to your left, you look to your right, or you look at the slide, right? You're predicting, you see the pupils of my eyes move, and that's a cue to you that I want you to pay attention to something that I'm probably about to point to in a half second or a second's time from now, right? It's so obvious you might not even be aware you're doing it. What happens if you're working alongside someone else and you can't see their eyes, or they don't have eyes, right? It's a little bit more tricky. So why not just rely, in this case, on people's intuition about social exchanges, right? I can understand what Baxter is doing by watching Baxter's arms and its eyes. For most things, that's enough. Okay. What are some other examples? How did your thinking about some of these technologies change?
If teenagers are texting while driving, it needs to be hands-off and probably via audio.
Okay, so hands-off and audio. Remember the P that we're dealing with here, teenagers. Are they going to say, oh, that's how I'm supposed to do it? Okay, I'm going to do it that way. Probably not. So think again about the P. How are we going to do this? We could ask teenagers nicely not to text while driving. That might get you some of the way there.
Lockout.
Lockout, right? So we're probably going to have to start to think about automating certain restrictions. How are we going to lock that out? How would we? Now we're getting into the T. We've decided how we're going to try and do it.
You can use the accelerometer in the phone so that when it's going over a certain speed that it can't have texting enabled.
Okay, so most phones have an accelerometer, and you can actually get a pretty good estimate of how fast the person is moving, generally speaking. But that's not going to be very satisfying, at least as a first approximation. Why not?
If you're riding in a car, you can't text.
If you're riding in a car, if you're on the bus, if you're on a subway, if you're on a train, unless I remember to turn off the lockout, I'm going to be upset, right? So again, it might be not the person using the technology, the person who is trying to text while driving. It's someone else in the car or someone who's on a train or a plane. So it's a good start, right? But can we now narrow this down? How can we lock out people that are in the driver's seat?
Detect if a Bluetooth device you're connected to is a car's like radio.
Okay.
If it is, you can initiate a locker like that.
Okay, right, so we can start to narrow in on exactly who is doing the texting.
Nowadays a lot of cars are becoming like smarter and they're having more technology involved in them.
Yep.
So maybe if we started having cars like connect to the phone of their owner, then it could shut down texting like when you're in that car.
That's it, right? So now we might broaden our investigation and say, wait a second, we may not be able to solve this just by altering the code of the texting app on the phone. Maybe we need to communicate with car manufacturers and develop technology that spans the car and the phone, right? Again, that has its pros and cons as well, but just to illustrate that a relatively simple task like texting can become exceedingly complex and also might provide a lot of opportunities beyond sort of a first order approximation, right? So if you are writing a texting app for a phone and you start to get some buy-in from car manufacturers, you might have your company might have a competitive advantage over other phones and other texting apps, right? We can make texting safe even for teenagers that are trying to do it while driving. How about the drone example? How does your thinking about writing code for the drones change given the situation?
Now with this change, it sounds like it's not really just flying the drones for fun. It sounds like there's a purpose for it. So your drones might need to have different abilities or specific controls. If you're trying to hold a banner, or if you're trying to have a camera to like get a view of the protest, like things like that.
Absolutely, right? So now with the change in context, the activity is now not very clear, right? What are the people trying to do with the drones at the large-scale protest? Are they trying to hold a flag? Is it media that's trying to get some video footage? Does anybody remember there was a attempted weaponized drone attack? Was it Argentina, Chile? I forget now, a couple weeks back, right? So are we talking about the bad guys now, or the good guys, depending on your point of view? Does it make sense to implement a super user function within this space? That there is a super user that can activate or restrict which drones are able to move in and out of this space? Again, depending on the larger context, that might be a good thing or a bad thing. Arlo.
I would say for the drone thing, any flying object like that you would see on airspace, it would make sense if there was like a super user, like I don't know, actually that'd be kind of a right to the government but having some super user airspace.
So now we've got a trade-off, right, between safety and press freedoms, right? So this now has nothing to do with technology. We've moved back into human space, right? What you'll see, even in the deliverables in your final project, as you start to develop your T, you'll start to realize that there are aspects of the P and the A and the C that you're not clear about, and you might have to go back to the users and the stakeholders and try and sharpen exactly what the P and A and C are, and then go back to the T. So when we get to the design part of this course, you're going to see that a lot of the design processes have this back and forth between developing technologies and prototyping and using those not as the final product, but to explore what are all the social and cultural and political contexts that surround this particular activity. Okay, I saw this tweet a couple days ago, which I thought was a great example of some people that did not think very carefully about HCI design. It's a robot lawnmower. If you buy a robot lawnmower, pay attention to this tweet here. Okay, context. Context matters. Okay, so again, we have this sort of cyclical design process that we're going to talk about. One of the nice things about this design process is often it makes clear new opportunities for technology that didn't exist before. So as we start to think about people and activities in context, we often in software engineering and HCI start to write down written specifications of exactly what the technology will do and won't do, right? When we talked about the cobot, we sort of started with safety. If you start writing requirements for code for Baxter, most of those things are going to have to do with safety, right? So we start to write down those requirements, and we start to actually implement those requirements or turn those written documents into code and or hardware, which gives us a prototype technology. We deploy that out in the world with our alpha users, our beta users, and then the general public. And we observe not just how people use the prototypes, but how people abuse the prototypes. Often they'll use the technology in a way that we didn't expect, which then suggests other technologies that either can support the function they're trying to adapt the original prototype for, or possibly new technologies to restrict the abuses of the original technology, and so on. Can you think of an example of a technology that when it was deployed for the first time uncovered new human wants and desires, and then a second technology that came in to support it?
With smartphones, a lot of things are now adapted to support the use of smartphones like ubiquitously. So
Okay.
from installing wireless charging ports in cafes or making Bluetooth accessibility like everywhere.
Absolutely, right? So once the first smartphones started to be deployed, there were millions of opportunities that opened up for technology, right? If anything is rewiring this world more than anything else, it's these little guys, right? Other examples?
Maybe like when computers first came out, people wanted to print stuff, so then like printers became a thing.
Absolutely,
Like,
yeah. That's right. So you got all this stuff on the screen. I would love to print it out and read it. What about the advent of social media platforms? Once they started to arrive, what other opportunities did they suggest that didn't exist before the social media platforms existed?
Advertising for companies, publicity.
Okay, so advertising already existed, but advertising on this novel platform. I'm looking for not something that already existed in the physical world or in other media. Brand new way in which people wanted to interact with technology that was suggested by social media platforms.
Front-facing camera.
A front-facing camera, that's a great example, right? That wasn't immediately obvious that would be useful. Yeah. Other examples?
Post a selfie of yourself with our product.
Post a selfie of yourself with our product. Yeah, exactly. So a particular kind of advertising strategy that just didn't exist beforehand.
Like specific user data-driven advertising.
Okay, right. So personalized advertising. Again, that really didn't exist before social media platforms.
There are a lot of applications that assist with social media apps, like for editing photos or things like that.
Okay, absolutely. Hashtagging. What did hashtagging mean before social media existed? Now, what opportunities that supplies, there's a whole lot of them, right? But there was a whole new thing. This is a way of interacting among people that just didn't exist beforehand, right? And it has its particular aspects, pros and cons. We could argue that all day. But it is definitely, unarguably, a novel thing, right?
I mean, it's categorization in another form, but it's I mean, like it's a new like focus and like specific genre for that. But I'd say that like among the people with social media, it's rather like the first way to categorize. We've done that.
Absolutely. So categorization, or pointing at a thing or a phenomenon and coming up with a name for it, that of course existed before, right? Hashtagging kind of made it easier. That's true. Okay. So we're going to spend most of the time in this course focusing on this feedback loop, the opportunities. Creating requirements, or going from people and activities and context down to the technology, writing the requirements, that's sort of much more within the space of software engineering. But it's worthwhile just thinking about this briefly. What would be some requirements for this cobot that works closely with people? So let's just sort of think about requirements as sort of one sentence. This technology should ... or this technology will not ... What are some one sentence examples you could think of as requirements for the cobot?
You should be able to shut it down easily.
Absolutely, right? So on all cobots, if you look carefully, somewhere on the robot's body is literally a big red button, right? Stop. Most technologies that are potentially dangerous to humans, they have something like a big red button, and often it is literally a big red button. That's a good example. We will ensure that on Baxter there is a big red button that regardless of where the human is standing, at any 360-degree position around the robot, that human can see and reach the big red button. That could be a requirement that we build into Baxter. What would be a requirement, again, a one-sentence, this technology will or this technology will not, description for the driving-proof texting app?
It needs to have like an opportunity to send out an emergency text.
Okay, so there should be an opportunity to send out an emergency text. Okay. Other examples?
you should respond to people who text you while you're driving to let them know that you're not informing them.
Okay, exactly. So we want to think about what about incoming texts? How are we going to deal with them? We might start to write some requirements around that. Okay. Let's switch now, and instead of thinking about requirements, think about opportunities. So at the moment, Baxters are mostly relegated to factories, but the robots are coming, autonomous cars. You might find yourself in the not too distant future working alongside a cobot, or there may be two people working with a cobot, one on one side and one on the other. What are some opportunities that that kind of technology would allow?
Just say doing more like the dangerous activities you want to do in like a factory, you have robots instead of humans.
Absolutely. So if you have 3 people working together, human, robot, human, they may be working in very close physical proximity. Is there a way in that physical context, within that literal space surrounding those 3 people, for the robot to very easily take over the dangerous parts of the task and leave the non-dangerous parts for the humans? We could write that out as a requirement that the robot will do this. It will immediately assume control over dangerous parts of the task. Then we need to write a whole bunch of other requirements for how exactly will Baxter signal that to the other humans and so on. So we're kind of back to requirements now. What about opportunities? What other kind of collaborative tasks might multiple humans be able to engage in if there are also cobots thrown into the mix?
Like if you had a robot farm or something like that, where there's a lot of physical labor, it's also a self-sustaining, or just one business.
Okay.
You could have that person able to analyze the kind of things that are going on and the new time.
Absolutely. So maybe if we thought about a farming situation, the farmer may no longer actually be doing the farming, right? They may be doing something a lot more cerebral, like analyzing the data coming back from the roboticized tractor.
There's a few restaurants now that are letting robots make their food, which allows people to work on things like customer service and cashier.
Absolutely. So you might enter into the service industry and restaurants because you're interested in interacting with people and you're interested in food and wine and so on, and you want to be part of that world, but not be doing the repetitive task of actually serving the food, but engaging with people on a social level, right? That's kind of difficult the way the dining world is currently set up. Okay, I'll leave you to think about that one as well. This is, as you can see, it's a little bit trickier to do because we're trying to think about something that doesn't really exist yet, right? And this is always hard to predict what the killer app will do. I doubt when the developers of social media platforms first put them out there, they had any inkling of this idea of cyberbullying. Right? There's another sort of novel social pathology that didn't really exist before. Now it's a thing, right? Unfortunately, some of the opportunities are negative rather than positive. You get enough practice in HCI and you get better and better at thinking about these opportunities. Okay, so now what we're going to do in the rest of this lecture is we're going to take P, A, and C and unpack them a little bit. What exactly do we mean by that? Well, let's start with people. Again, people differ from one another along multiple dimensions. What are those dimensions? Again, like we saw before, some of them are obvious and some of them are less obvious. Physical differences. Some people can see better than others. Some people can hear better than others. Some people have better or lesser motor control. What kinds of people have less motor control?
People with Parkinson's.
People with Parkinson's disease, that's a pretty obvious one. People missing limbs. What are some of the less obvious groups?
Like real young people?
Young people, children, right? So it's hard for a young person to use leap motion because it's hard for them to hold their hand still, or it's hard for them to think that that's what they should be doing, right? To a young child, you wave or you smash things, right? That's a good thing to think about if your testing group for leap motion includes young people. Someone who has Parkinson's may have a hard time using the device, but they're probably not going to try and smash it to bits. Okay. Different body shapes, sizes, and colors. These things can definitely matter depending on what the device is, especially when it's real-time video. If you're recording video from the real world and you're doing pattern recognition, humans differ visually quite a bit, and that can matter. Psychological differences. Two people might look very similar, but act very differently. They might have different spatial or temporal awareness. Some people describe themselves as visual creatures. They need to be able to see something visually to understand it. You may have a group of people that don't speak English, so writing English text to the screen isn't going to help them very much. In your final project, this is a good time to mention this, you cannot use English text. You're going to assume that your final project might be used by a non-native English speaker. So everything you want the user to do in your final project, you're going to have to present a visual metaphor, a picture or a video, or audio if you want, as long as it's not English, to tell the user what they're supposed to be doing. It's a tricky thing to do. Okay. Cultural differences, we just mentioned language differences. We already gave the example of the buttons. If you're a native Hebrew speaker or reader, what do these buttons mean? And assuming you've never seen the internet before.
It would be backwards from what we would expect.
That's right. So this is previous, this is next, fast forward, and rewind, right? You know that, I just told you that. You're probably looking at that and you're wincing, right? Because I'm breaking your intuition, right? Obviously, this button means next. How could this button ever mean previous? That's crazy, right? Be aware of your own biases here. So we need to, again, that one might be relatively obvious. There's hundreds of other examples you can come up with. Finally, and most importantly, and again, most subtly, is this cognitive difference. As I mentioned, the human brain, as far as we know today, it's a prediction machine. It's always making predictions about what's going to happen. That's universal, more or less, across everyone. What differs is what the predictions are. So a native English speaker who sees this for the first time will predict when they click on that they'll see whatever they're looking at speed up into the future. A native Hebrew speaker, when they click on this, will expect to see whatever they're looking at go into reverse, right? If that doesn't happen, that's probably the end of their interaction with your technology. So be sure that you know for different people what are the predictions they have when they interact with your device for the first time. Okay. Usage differences, right? Some people are happy to work with computers and consider themselves power users. My father is not one of those people. I've been trying to teach him to use a computer going on 23 years now, and I'm having limited success, right? Some people aren't very good at using computers. Some people hate using computers. Some people have a job where they have to use computers for certain things. That matters, right? So novices tend to use computers very differently from the way power users like to use those computers. Most of the people developing software belong to which group? Power users, right? It's obvious keyboard shortcuts is the way to go. Do we even need to put icons? We don't need icons. Let's just do everything at the terminal and the command line, right? It's obvious, it's intuitive, it's fast, it's efficient. That's obviously the answer. Depends on who's going to be using your technology. So novice users, advanced users, and the hardest users to create technology for are discretionary users that are being forced to use technology in some way. Anybody here had any experience with PeopleSoft? It's the administrative software side of UVM. I apologize to you on UVM's behalf. I also suffer under the regime of PeopleSoft. Especially if you're faculty, you have no choice. You have to use it. There you go. Okay. Okay, so that's people, and again, we're going to spend a lot more time unpacking these categories. Just keep in mind some are more obvious than others. Let's think about what people are trying to do. There's a gazillion different things that people do with technology. We can't really itemize all of them, but we can try and classify these activities into different categories. There's arbitrary ways that you can come up with these categories. For this course, we're going to sort of look at 10 of them. The first 4 have to do with the temporal aspects of the activity. How does the activity unfold in time? How regular or infrequent is the activity taken? Some people are checking their email and sending emails throughout the day, all day, every day. Other people wait to do their email just in the mornings or just in the evenings if they're lucky to be able to do such a thing. Usage history. So if you look at a technology, is that technology, the group of people that are using that technology, is the level of usage relatively constant, or does it spike? Does it have peaks and troughs? What are some examples of technology that if you were able to see the user traffic looks pretty steady? And what are some other technologies in which if you were able to look at the user traffic, it would peak and trough?
Well, like you said, I feel like emails are pretty continuous, but for interrupted, it might be like course registration. You only see that like a few times in a year.
Absolutely, right? So the course registration is definitely going to be pretty peaky, and people that develop course registration for universities maybe didn't think about it up front, but they definitely do now.
Uber or Lyft is going to peak around rush hour.
Uber and Lyft, so ride-sharing services peak around rush hour. That's an obvious activity and context in which it's going to peak. What are some less obvious situations in which Uber and Lyft rides peak?
Around 3 a.m. when people are jumping coming home.
Absolutely, okay. So when the bars close, yeah. Holidays, yeah, absolutely. The more subtle, the better. There's some that are much less obvious.
When it's predicted to be sunny out, but it happens to be rainy.
Okay, when it's sunny or rainy, so this is a good one, right? Weather matters. When it gets really hot, Lyft and Uber rides also peak. People might not necessarily need a ride, they need AC more than anything else, right? So sometimes it's not even really the actual service, right? They'll come up with an excuse for a ride because they need some air conditioning, right? Okay, response time, continuous versus interrupted. So is the activity that the user using the technology for, are they carrying out a task where they're going to do part of the task, leave it, and then come back and do it later? That's an important one, and it really influences the way you think about developing the technology. And to illustrate that, let's look at the parable of Tempus and Hora. This was a parable given by Herb Simon to make a point, and you'll probably see the point in a moment. In the parable, there were two watchmakers, Hora and Tempus. They both made very fine watches. The phones in their workshops were ringing frequently, so new customers were constantly calling them, asking for them to build new watches for them. However, Hora prospered while Tempus became poorer and poorer. In the end, Tempus lost his shop. What was the reason behind this? The reason is that Tempus and Hora built watches in different ways. The watches themselves consisted of about 1,000 parts. The watches that Tempus made were designed in such a way such that when they had to put down a partly assembled watch to answer the phone, it immediately fell into pieces and had to be reassembled from scratch, from the basic elements. Hora, on the other hand, had designed the way, actually this should not only say designed his watches, designed the way in which he puts the watches together. The two designers basically had the same kit of parts, but they put them together in different ways. Hora had designed the way he put the watches together in a way so that sub-assemblies of into about sub-assemblies of 10 components each, and these 10 components held together. 10 of these sub-assemblies could be put together to make a larger sub-assembly of 100 parts, and these 10 of these 100-part sub-assemblies, which held together, could be put together to make the entire watch. So here's my little visual representation of this. What is the point of this parable? What is the design aspect that Simon is getting at?
Modularity of having things be like stop after.
Modularity, right? So designing things that are made up of things that are made up of things, and so on. So this, you can also think of this as hierarchy. Hierarchy and modularity are related to one another. This is watches. How is that principle embodied in software or software and hardware that supports tasks that can't be done all at one sitting?
Well, sorry, I was gonna say like the save functionality, where you
This-
can save and then come back.
Okay.
That's slightly different.
That's slightly different, but thank you for raising that point, right? So saving and finding your place again, that exists in a lot of technologies today. And that's important, but that's not quite the same as something being modular. You can have something that's non-modular. It's made up of 1,000 pieces. You're marching through those 1,000 pieces and you can save and find your place again. Where is this idea of modularity embodied?
Class files.
Class files, absolutely, right? So code development itself is all about modularity, right? So you have individual lines of code, the base elements of these watches. Lines of code can be put together into a class. Classes can be put together into larger classes. Object-oriented programming, the whole idea there is about modularity. Now that's useful for coders. Are there examples of technology that supplies this idea of modularity to people that don't necessarily code?
For like language learning apps, you have like lessons within them. So like if there's a larger subject of like sports, within it there's just like talking about sports, the verbs used in sports, stuff like that.
Absolutely. That's a great example. So language learning software, right, is usually organized in a hierarchical, modular manner. Imagine a language learning system that said, okay, you're going to learn the following 131,000 words. Let's start with word number 1. You got that? Next, next, next. You still save your place and continue. You can learn a language that way. It's pretty painful. Better to help people organize things hierarchically. Right? You're looking at one slide. This slide is part of an individual slide deck. This slide deck is part of theme number 1 of 5 of this course. You're probably taking multiple courses here at the university. We tend to organize our technology and everything in our world as best we can in a modular, hierarchical manner, because most of the things we want to do, like learn about HCI, you're not going to do in one sitting. I hope when you finish this course, you go and work in industry for 5 years and you say, oh yeah, I remember Professor Bongar talking something about the Tempest and Hora parable. Where was that? Of course, you could search, but you could probably go back and locate it because I try to organize this course in a hierarchical manner. Okay, you have a quiz due tonight. Please do get started on Deliverable 2, and I will see you Thursday morning. Thank you.